In this video, we'll discuss the basic principles of probability. Now, probability is the measure of the likelihood of an event occurring. To get that, we need the sample space, which is the set of all the possible outcomes. For example, if I have a die, it has the sides 1, 2, 3, 4, 5, and 6, so that represents the sample space. Now, within a sample space, we'll be looking at the event, which is the collection of outcomes to which probability can be assigned. This is always a subset of the sample space. So if we think back to our die, an event could be rolling an even number, because that would be the sides 2, 4, or 6. Now, some important concepts that we need to recognize with probability is that the probability of a future event occurring can be characterized on a continuum of from impossible to certain, or from 0 to 100%. For example, when we think back to our die, that would be a 1/6 chance of rolling any given side, like a side that is the 2. Also, probability has no memory. This is important. This is where places like Vegas make their money. It's because people think of probability having memory. It has no memory. Every time I roll the die, it's a fair die. So I have just the same chance of rolling the number 2 on the first time as I did on the 50th time or on the 100th time, because it's fair. Every time I pick up that die, it is the same chance of rolling that number. Now, we have 3 fundamental principles of probability. First, if 2 events are equally likely to occur, their probabilities are equal. Second, the probability of an event is the sum of the probability of the outcomes that create that event. And third, the empirical probability, which is when we do an experiment, will continue to come closer and closer to the theoretical probability the more times that we perform the experiment. So let's look back to our example of rolling an even number on a die. We know the sample space was 1 through 6, and we know that the event is to roll a 2, 4, or 6. Let's apply those 3 principles. So the first one, about events that are equally likely to occur, will have the same probability. Well, on a die, all 6 sides are equally likely to be rolled, so we can say that the probability of rolling a 1 is equal to the probability of rolling a 2, which is equal to rolling the probability of a 3, which is equal to rolling the probability of a 4, which is equal to the probability of rolling a 5, and rolling a 6, which all of them then have to be 1/6. Now, the probability of an event is the sum of the outcomes within the event. With this principle, it says what we can do is we can add up each of those probabilities for the event being even, which would be the probability of rolling a 2 plus the probability of rolling a 4 plus the probability of rolling a 6. And that will give us the overall probability. Well, that would be 1/6 plus 1/6 plus 1/6, which is 3/6, or 1/2. So there's a 50% chance of rolling an even number. And the third one, say that the empirical probability will continue to come closer to the theoretical probability. So what can happen here, say that we know the theoretical probability we just calculated was 1/2, so a 50% chance. But that doesn't always happen in real life as we are rolling the die. Say that the first time we do the experiment, we roll a total of 12 times, but only 3 of those come up even. That's the empirical probability in this case, which is 25%. And that's possible because it's a very small sample size. Now, say we get a larger sample size of 60 times. This time, 28 of those 60 come up as even. And that comes up to just under 47%. Much, much closer to the theoretical probability. Now, say that we get to 500 times. In this point, 251 of those rolls were an even number. That is barely over 50%. It's 50.2%, because the more and more times we roll the die, the more and more times and closer to the 50% that our empirical probability will become. Now, we can also calculate probability when we have given information. First, we'll need to determine what's our sample space and what's the frequency of that sample space, and then we're going to take the frequency of an event and divide that by the total frequency of the sample space. Let's look at an example. Say we have a group that's been surveying 80 people's favorite color, and this table provides the current frequencies for each color. What is the probability that the next person asked will state green as their favorite color? So we're going to use this table to help us estimate that probability. So first thing, the frequency of green currently is at 12. That's the event's frequency. We also need to know the sample space's frequency, which is 80. Well, how did I get 80? Well, we have the fact that they say they've surveyed 80 people. Also, if we take and sum up all of the frequencies, that should give us 80. So to calculate the probability of being green, we're going to take the frequency of green divided by the total frequency. That simplifies to 3/20, which is about 15%. So we would say there's a 15% chance that the next person states green as their favorite color.